Hello everyone. We welcome you to this session by upGrad, the first of our series of 3 for Android developers. The first one that we have is around the must-haves for an Android developer. And today we have with us Aman. Aman is a developer advocate at Twitter. Yeah, and Aman's with us today. Thanks for being here, Aman. Yeah, we welcome you. We welcome you to this webinar. And to just give a bit of a background about Aman, Aman is a developer advocate at Twitter, and we'll just talk about what does a developer advocate exactly do. Before that, Aman has extensive experience in the field of Android. Aman is also closely associated with community building in Bangalore. He's a key member of BLR Droid and an organizer now as well, has been for the past 4 years. Aman, before that, has worked with organizations like Haptic. He's also run his own design development studio before that as well. And so now over to Aman. And Aman, just a slight question before we start, right? What does a developer advocate exactly do?
So, hello everybody. My name is Aman. I work with Twitter and I look after developer advocacy in APAC for Twitter. So coming back to the question, what does developer advocacy actually involve? My job is to talk to a lot of developers through meetups, through these online hangouts, webinars, and all the other places. Tell them what are the tools that we have for them that they can use in their day-to-day life and make their lives easier. And if they have any feedback, which I can take back for my teams. So it's a two-way road. I act as a bridge between developers out there in the wild building cool stuff and Twitter. So some people confuse me with being a literal advocate, which I'm not. I have nothing to do with the legal department. So yeah, feel free. I'm just a developer who advocates you guys inside and outside Twitter.
Sure. So Aman, this topic, right? I mean, must-haves for an Android developer, and you've been associated with Android for quite some time now. So do you just want to, take this ahead, and I'll just leave, I'll let you talk about this with our, audience. Yeah.
Yeah.
And we'll
sure.
come back on. I'll come back on for the Q&A at the end.
Sure.
True.
So guys, the topic. Okay. Yeah. So guys, the topic for this webinar is the must-haves for Android devs. When I say dev, I mean developers. And we'll cover a few of the topics here, which will largely relate to the mindset that you should have when you're starting to build Android apps or you're starting to become a developer. And after that, what are the tangible and actual things that you should be careful about when you are building Android apps or starting to learn about it. So let's begin. A little note about what we'll cover. We'll cover 3 main things about what is Android and how you should look at it, and how does a usual day of an Android developer looks like. And once that happens, I'll tell you about what are the few things which you should be keeping in mind when you are going ahead and building apps or just learning Android. So first, what is Android? One of the questions that you will be asked when you go to the interview. First, a mobile device operating system. I did not say a mobile phone because it has now expanded to more things than a mobile device with mobile phones. It did start with being a mobile OS back in 2008, I guess, but now it's present on TVs and lots of other places. So it's an operating system which is highly optimized for devices which are mobile. It's also a tech stack and a collection of APIs which lets you build applications on top of it. So if you have been a Java developer in the past, you'll kind of understand this. It provides you a high-level platform where you call certain methods to do certain things, and you just build your applications. So for example, instead of writing your own video player, you'll call a system level method or a particular view to get the system video player and then get started with it. So you don't have to write your own code to just get started with the video player. Some platforms, some other OSs might want you to do that, but in modern day engineering, hardly any OS will have you do that. Android is also one of the mobile OSs out there in the world. And the interesting fact about it is that it's almost 70% of the people who are using mobile phones are using it on Android. Okay, and that means when you're building an Android app, first you will have a lot of reach for your apps, and second, it will be tough to reach so many people. So we'll cover all these points as we go ahead. Life of an Android developer in a day. This looks like this. I mean, like for example, you have just put your mouth out from a car which is speeding 100 miles an hour. So things are bombarded at you every day. This platform and the ecosystem is under heavy development every single day. So there is new stuff coming out, new libraries, new OS. Every 6 months, things become better and they improve. And over the last few years, Android has become really, really huge. So when you're coming up to learn this, be prepared that this is going to be massive. It's going to be a huge air blow in your face. Now, first thing first, when you start Android, what should you be doing? You should be knowing Java, your old neighbor from your college times. You should be knowing event delegation model, how event delegation model works in Java, because in Android, if you have already been a programmer in your engineering college days, you would notice that you're no longer going to write programs which will wait for input on a console. When I say a console, that means command line, which could be terminal in Linux or Mac, or your command line interface in Windows. So you're no longer going to write programs which will wait for something to happen on terminal and then move ahead. The apps you'll write will contain programs or code or logic which will execute at once and then wait for the user to do something. That's called event delegation model. So you'll have to understand in Java how that event delegation model works, how event happens, how they are triggered, and how they are listened and responded to. The same concepts work here. You'll also have to know how interfaces work and how callbacks work, because Android uses all of these concepts very heavily. So you'll be doing a lot of things which are long running. So you'll be doing them and in a way where you start them and you instruct the process to tell you when it is finished. So when you start them, it's like might be normal process, but these processes tell you about the processes being finished as a way of a callback. That's why it is called callback, because they call you back when they're done. So you have to know how callbacks are done, how callbacks are implemented, and how interfaces are used sometimes to create callbacks. Okay. You'll also have to, I mean, it will come handy if you know inner classes and anonymous classes, because many times you'll be writing that. I can take another 2-3 sessions explaining all of these, but that's not the topic. So brush up your Java skills, specifically these 3-4 things. And yes, you must know how threads work. Multi-threading, you must have heard in your engineering days. You have to know how threads work, because what happens, any operation which is slightly longer in an Android app, and when I say slightly longer, that means let's say longer than 3, 4, or 5 seconds. If you're doing that on the main thread, the Android system is going to halt for that. It will not be able to process user input. People will be clicking a button and nothing will be happening because you're doing something which takes a long time. For example, downloading an image on a UI thread, and then the system will say this app is not responding. Your users will get to see an ugly dialog box, and they'll get a chance to either close your app or wait for it. So learn how threads work and how they are used to do parallel or multiple things at the same time, and because we will be using threads in Android. The Android overall system is designed in a way where it's very user-centric. So if you're doing something which is long running and your app stops responding, the system is going to warn user for that and give them options. And you don't want to be that app which gets killed by the user because it's doing something incorrectly. After that, it will be great if you understand how garbage collection works. And apart from that, what happens and what constraints your programs are put into when you run inside a JVM. So both are kind of interconnected. When I say garbage collection on JVM, that means to save memory, to make sure that multiple apps can run at the same time, your apps are going to be killed at some time. Okay, so either the user swipes it out or the operating system tries to make more space. Your apps will have to be swiped out and swiped back in. So when you are developing, keep this in mind. And Android gives you enough ways to deal with this situation, but know that this will happen. Okay. Apart from Java, it will be great to understand how client-server model works. When I say client-server model, I mean the server becomes the web server, and your Android devices become client. So a very industry-heavy terminology to address this is called thick client. So let's back up a little bit and see how people have been developing so far. We all first started with desktop applications, which would run on our desktop computers or laptops. Those were the days of Microsoft Word and Microsoft Excel. Internet was primarily being accessed by slower means such as dial-up, etc. And dot-com boom probably did not have happened. So back then, if you were a software engineer, you would be building things which would run on a laptop computer. And if you have to interact with internet, it will most probably be for updating the software itself. Then came the era where people started building websites. So, and when you're building a website, what actually happens is you host a lot of stuff, including your business logic and the script which will make things happen on the server. Your browser makes a request to the server that I want this particular thing and gets something back as a response, processes that response, and displays to you. Every browser has this thing happening in the background. This is, in the very basic manner, it's called a client-server model of communication. So your browser is the client, the server is the web server, the browser talks to the web server, asks for some resources, the web server responds with it, and the browser interprets them, parses them, and shows that. A very interesting thing in that particular area is the layout engines. So whatever HTML or CSS is downloaded from server is passed by a layout engine. And then layout engine is the thing that decides how things are going to be laid out on the screen. So the different browsers have different layout engines. For example, Chrome and Safari are based on WebKit. Mozilla is based on Gecko, and Internet Explorer is based on, I think it was based on Trident. Your mobile browsers also are largely based on WebKit. So these are the layout engines. This is a little off topic, but a good thing to know. So in that era, your browser used to be the client and the server used to be server. Now there is another thing which has come. It's Android or your mobile apps, which is going to be the client and requesting things from the server and displaying the responses. They'll also be collecting things from the server in the form of user input and sending it back to the server. Okay, so once again, your mobile apps will be thick clients, which will be asking for data from the server and displaying them. At the same time, they'll be collecting some data from the users and sending them back. So if you understand this model of how client-server communication happens, it will be great to build apps, because most of the times you're going to build apps like these. Okay. Apart from this, if you also understand how HTTP works, it will help a lot, because you will be dealing with the libraries or APIs which work on HTTP, and it will be great to know how the protocol works. Okay. Next thing. This is more about mindset. It doesn't have to do very semantically with how you become an Android developer. You have to think like somebody who makes stuff. Okay, we are obviously learn about how you should be building Android apps, but even before that, you should be thinking about how to make things. When that happens, you will be more solution oriented, and then once you know how to build things, you'll be able to pick up whatever tools you have to solve the problems. So when you approach things with this, you'll be able to think about the whole holistic solution to a certain problem, not just think as mobile or Android developers. It will certainly help in building Android apps, but have this thing in your mind. Most of us start things with great enthusiasm, but somewhere around the line, you lose the interest. So try to be understanding of the fact that this whole thing is going to be a marathon, not a sprint. So prepare for it. It's going to be a long running process. You'll You'll be doing a lot of stuff. You'll be spending a lot of time. So don't give up. Prepare for things. Start well and finish well as well. Now, after this, let's talk about what happens when you start your journey. Android, all over these years, has become a very big platform. It started as a mobile app platform, and it has now gone to tablets, to cars, to all the different places. It's now going to people where are putting it on Internet of Things, Raspberry Pis, and whatnot. It's become huge, and that's why throughout the years, the official documentation of Android has also changed. When you begin, please make sure that you make yourself familiarized with the Android documentation. It will take some time. There is a lot of stuff going on there. So spend some time and try to understand how things are written there. There is a training section there as well, which is very basic. And in the main documentation, things are quite heavy. So familiarize yourself with the documentation, and because that's the place you'll be spending your most of the time to learn new stuff, apart from the courses that you're taking. You'll also sometimes get stuck and there'll be nobody around to help you. Then things like Stack Overflow questions or IRC channel of Android or your local communities, no matter which city you are, there'll always be developers who are doing the same thing, and that community will help you. So try to be in touch with all these three things and surround yourself with developers who have gone through the same journey you have gone through and can offer you some advices. Let's see what's next. Device constraints. So now, this is something you'll have to be very careful about. If you have been somebody who's coming from a background of desktop app development or web app development, you have to understand that these devices on which Android runs on, don't have unlimited power source. They're not connected to an AC power supply all the time. They run on batteries, and batteries run out. They have a very small screen size, and the interface is touch based. It's not mouse based. What that makes happen is when your screen size becomes smaller, you have to be very, very judicial about what you're going to display there, because people generally wouldn't swipe a lot if they are seeing your app for the first time. So decide what's important, what they want to see first, display that. When you're designing your touch areas, your icons, and the places where you want people to touch, have them at least 50 pixels or 50 dp, as we call it in Android. Have them at least that much wide, because our finger touches are not as precise as a mouse. So people might end up touching somewhere left or right or top or bottom from the actual touch point. So have your touch area slightly bigger. These devices will also run on metered network. When I say metered network, I mean network which is 3G and for which people pay a high price for. For example, you might be in a city where you pay $1,000 and you get virtually unlimited internet access on broadband and Wi-Fi. But on your 3G, it's still costly. You still have to pay close to 250 rupees to get 1 GB of internet. It's not even unlimited. And you almost always use these devices in areas when you're mobile, when you don't have access to a charger, when you don't have access to a Wi-Fi device, when you don't have access to a bigger screen. So every resource that these devices have becomes very crucial. So be very judicious about how you do things and what all you do. If you can offload stuff which is very heavy to the server, do that. Expose that as an API. An example of that would be, let's say you have to take a picture from the user's phone and you have to apply some cool effects on it. If you think these effects are heavier for one Android device to handle en masse, you can have these pictures sent to the server. The server is a big machine, a lot of resources, very powerful computer. That will do all these things on the image, and the processed image can then be sent back to the Android device. One of the example of this is the latest app called Prisma. One of the reasons why they're doing this is because they're employing a lot of neural networks to do a lot of things on the app. So that's why they have to send it to the server. But yes, right now, neural network can be an example of something which is quite heavy for a mobile device to handle. So they're doing it on their server. So resources are crucial here. Understand this point, and when you approach the building, think from this perspective. You might think that these devices have become very powerful as your old computer, for example. There are devices shipping with 6 GBs of RAM and octa-core processors and 64 GBs of flash storage, secondary storage. To be very frank, 7 years ago, this used to be a configuration of a mid-range laptop. Yes, these devices have become very powerful, but they still have a trouble lasting for more than a day, right? And they still will run on a metered network, which sometimes is costly for the user. So you have to be very judicial about using the resources. Now, when you are operating in the client-server environment, you'll most often be sending data to the server or receiving data from the server and displaying it. When these servers expose data, they expose this in forms of API. What I mean by API, the full form API is called Application Programming Interface. So if you're building an application and if you're programming an application and you want to interact with some services, this is the interface that you interact with. For example, if you have to post a new tweet, you have to interact with our REST APIs, have that tweet, have it sent to us in a certain data format, and then we'll post it on the behalf of the user. If you have to view tweets as a result of a certain search, you'll have to send us, our servers, Twitter servers, some query that you want to have a search against. And once that search query is processed, whatever results we get, we will give them back to you in a certain data format. You will then be able to parse it. So you should have to know how to parse it and then display it. What are these data formats? One of the most popular data formats is JSON these days. That's called JavaScript Object Notation. So understand how this works. You will have to be parsing a lot of JSON on the device to send and receive data both ways. Another data format would be XML. It's slightly dated now, but some of the applications, some of the libraries still use XML a lot. So at least get yourself familiarized with JSON and XML. It's very easy to pick. You'll probably be spending max 5-6 hours in one go to get a basic hang of these things and how to work with it. Okay, when you actually go beyond JSON and XML, and if you want to be very efficient in sending and receiving data in small packets, you should be also looking at protobuf. Next, reuse, don't reinvent. What I mean by that is whatever you might want to build in terms of getting your application out there, there's a very high chance that somebody has already done that. For example, people have already been doing network communication since a long time. They have already been loading images from a web server URL since a very long time. That means they have already evolved and gotten better ways to do that. So you already have great libraries which do network operations for you, which do database operations for you, which do image loading and image caching for you. So look into these libraries and use them whenever possible. Okay. Now, this is a tricky area. You might start looking into libraries, and then you'll probably start looking for library for every single thing that you have to build and start putting libraries together. But be careful, because if you have to do 10 things and for 9 of them you are getting one single library together, all of these 9 different libraries are going to add up to your code base. Okay, so be very judicious on what you need. Go read through the code of these libraries. It will do 2 things. First, it will make you a better programmer. It will help you understand how a nice code is written so that you can come back and write your own code nicely. And second, it will make you a better engineer. One of the third bonus thing that will happen is maybe they are doing that. For example, there's one image loading library. They are doing 5 different things in terms of loading an image, but you need just one of them. And for just one of them, doesn't make a lot of sense to get all those 5 and increase the size. Maybe you can just read the code and replicate the same thing at your end as well. So it's completely up to you, but do look at the libraries, look at their code, see how they are made, and if you can use them. GitHub is filled with libraries, and there are so many other places you can get libraries. For example, Twitter has its own platform called Fabric, and we deploy a lot of these SDKs and kits that we call, as we call them, to make your lives easier. Okay, so look into the code that has already been written. Use that if it suits your case, but be judicial. Look into that code base as well and learn from it. We talked about certain Java concepts in the very beginning of this slide and the webinar. Apart from that, even though Java is very essential to Android, Android has its own some of the very interesting components. For example, intents and message passing, broadcast or services. Let's go through one of them or all of them one by one slowly. Intents is a way of one application or anything running inside an app to tell the system that it wants to do anything. So for example, a phone call arrived and intent is passed throughout the operating system that there's a phone call and the phone wants to receive it. Your dialer app is quickly jumped up, and then it is opened and you receive the call. How does this happen? You figure out. For example, you are looking at a web page in your browser and there is a Google Maps link. When you click on that link, Google Maps opens in the app, not in the browser. How does that happen? How does it happen? When you click the link, there's an intent which is fired, which says, I'm trying to load this maps URL. This intent is got by operating system, and operating system asks all the apps that it has registered to see which of the apps have registered to listen for this particular intent being fired. That is called probably share or view intent. So it turns out that the Maps app is trying to listen to a certain URL scheme whenever it is fired as a broadcast or intent, and it opens itself. An easier example will be, for example, you want to share something from one of the apps to WhatsApp. So you click your share button, then an intent is fired to the operating system, which says this app or this user wants to share some text. The operating system already knows that these are the list of applications. This is a list of applications which can handle text being shared. One of them becomes WhatsApp. So it gives you that list. You choose WhatsApp. So this text message is passed to the WhatsApp application as an intent, and this text is added to this intent as a rider or as an extra data. It's sent to WhatsApp. WhatsApp wakes up, gets this intent, parses this data, gets the data out, knows who you have to send it if you have already selected, or you will probably select it, and then you use this data to share it with somebody. So this is how intents are used across Android system to communicate, pass the message around, or just show an intention of doing something and let the OS handle it. After this comes broadcast. Broadcast, as the literal English word says, is a message sent en masse throughout the system saying that something is happening. For example, battery became low is a broadcast that is sent across the system. One of the app that is listening to battery getting low is that pop-up that you see when the battery gets low and says battery remaining only 15%. When you put your phone into charge, that's again a broadcast that is sent out. When a message is received, SMS, that's also a broadcast that is sent out. These broadcasts can be system-wide, and it can be app-specific also. You as a developer can create this system, can call this or send these system-wide broadcasts, and you can also send your app-wide broadcast as well. Okay. Then comes services or intent services. One of the key unique features of Android is that it lets you do a lot of things in the background. How does that happen? One of the major components of that is in services. So services, you might have studied somewhere called daemons. They run in the background. They wouldn't have a UI, and they can live for long. Okay, so intent services are also similar. Services can live for long, and intent services basically have the intent of doing something in background, and as soon as that thing finishes, shut themselves off. A good example of this will be sending a big file to a certain server. You want to do this in background. You don't want to do this in UI thread. and you want this background thread to be finished whenever this file upload has happened. So you spawn a new intent service, tell that this is the server address, this is the file, go upload this to the server and then shut yourself. Intent service just does that. So it's a lot easier, and it's a very compartmentalized component of services. It lets you do a lot of things in the background and then shut itself. So explore that. And last but not the least, activities. Activities are the things, the screens that you see. We call them activities in programmer language. So these are the UI that you will see. Okay, so there's a question. So, sorry for interrupting.
No,
You
that's
can
okay.
question. Okay.
Yeah, we'll do the Q&A at the end, no issues. Yeah.
Yeah, sure. We'll do the Q&A in the end, so don't worry about that. So these are some interesting Android components. You'll find more components as you go up, but these are the few things which will make it very different from Java. So just to not let you guys confuse, Java is the programming language that is used to make Android application, but Android also adds a lot more along with using Java so that you can build your applications. Okay. Some things that you'll have to remember when you're building Android apps. First of all, you cannot fix things remotely. If you have been building a website or a web portal, you have all the things on the server, and whenever a request comes in, the request goes to the server, response is served, and the data is displayed. Let's say there is a problem there. The data is not getting displayed nicely. You have missed some HTML, you have missed some div, there's some CSS property not working properly. What you can do, you can just go to your server, correct that data, and the next time anybody requests it, things will be okay. This cannot work in the apps. There are many things that you hard code in the app and you write code, then you build a binary which is called executable, which gets installed onto the devices. So it's pretty similar to how your MS Word would work or MS Excel would work on your computer, but on the mobile phones. How? So you would have remember Microsoft used to release new versions of their Office packages every few years. Why? You had to buy them and feed them in and then install it. Why? They could have done it internet-wise. Why? Because these are the desktop apps that are executable, that are given out as binaries, that are coded, and every time you have to upgrade them, you have to get the new binary and feed it in. The same applies on the mobile phones as well. Once you are going to launch your app, they're launched as a packaged binary called APK. This is sent out to every single device that downloads this app and is installed inside the app. So if there are things which are broken, which are buggy on a certain device, they won't go away until a new fixed build, binary build, is sent out and is installed on the same device. So don't think that there will be always things that you can fix on the backend. There will always be certain things. For example, your server is giving out wrong API responses. You can fix that. But there are things which you have done inside your app, you may not always be able to fix it. That means you should be very careful about what you are shipping. You have to test. You have to debug your code a lot. Android Studio offers some great tools for debugging. You have full logs. Whatever your phone is doing, you get to see in the logs and you understand what's happening. Use that. You have tools to measure memory consumption. You have tools to measure CPU consumption. You have now tools to measure network consumption. You have all these different tools available inside Android Studio. Use them, explore them. Start writing tests also. So what happens is you write these unit tests, which you start writing when you start building code. And in the beginning, they might not seem big, but when your app becomes big, they start making a lot of sense. Let's take an example. You're building an app which has only 3 features right now. And you think it's not a big deal, and I can do it later, and I just have a few simple features. But going down the line, you ended up having 50 more features in next 1 year. Now, the 51st feature that you are going to add might have introduced a bug in the first feature that you ever shipped. which is still there. And you have probably forgotten about it. So when you give this app out for testing to people, they'll test this 51st feature. They'll test this 49th or 50th or 51st feature, but they'll very rarely go back to this first feature and test it. So you'll just test 51st feature, 50th feature, and then ship it out. What happens when the first feature starts breaking in? You'll be in panic. If you had written a unit testing code before starting to build so much, what happens when your app starts building as an executable, as a binary, your Android Studio will run these tests first. And then only when these tests clear, then it will build the app. So in the same case, if you had written unit test for this first feature, when you are going to release a 51st feature, all these automated unit tests will be run again, and you will find out that this new feature has introduced a bug in the old feature. Let's fix it before shipping. Okay, so you do that. Even after all this, you might sometimes miss shipping some things, or you're just one human or 5 different people working in a team. You might just miss some things very genuinely, but when they go out, they start crashing. So have something which detects what crashes are happening, which detects how people are using your app. So use something like Crashlytics or Answers. Crashlytics does great crash reporting for your apps. So actually what happens when your apps are out there in the hands of users, and when they crash, you have to have a way to understand what's happening. So Crashlytics will let you have all these trackers sent to you and tell you what things are happening, how many people have had this crash. We'll send you the whole log. You can look into it. So explore these tools, use them, and have a mindset in the head that these apps are going to be disintegrated when they are sent out. So you need to know what's happening when they're out there. Okay, and one of the biggest mistakes that the developers, including myself, have made so far is we have certain technologies and we think around it. And I was also told this by my seniors, by my mentors. And what happens is you think I have these certain things. I have camera, I have GPS, I have this gyroscope, gyrometer. Let's build something around it. That may not be the most ideal solution. Think from the solutions or problems perspective and then see what all things you can use. The ideal solution may use camera or may not. The ideal solution may use a GPS sensor or may not. It may use a temperature sensor and may not. So think from a solutions perspective and then see what all you have. Another good point will be to have mentor. Find somebody who knows a lot, be humble, and keep learning from them. This will accelerate your learning like anything. So there's nothing more which will have. When I started, I did not have things like this webinar right now where somebody could come and tell what's happening. Even if I was willing to pay millions, there was nobody in India who would do that. I just had a very close group of friends and mentors who have helped me, made me learn. I used to spend a lot of time on forums in Stack Overflow and all these chats to learn, to read. So you have to teach yourself how to learn from mentors, have them, find them, and from the documentation and forums. You're reaching towards the end. When you go into the professional environment, you will be not just a coder, you will be an agent of change. Why? Because you're not a traditional developer. A lot of designers you will be working with wouldn't have worked on Android apps or mobile apps before. They would be coming from an era where they would be building websites. So you'll have to be a part coder who builds stuff and part designer who tells these designers that what you want. Nobody will understand Android as better as you do. You cannot even expect your leadership to understand that. So be prepared that you might have to be the change agent in the professional environment where you go. You will be put in teams, but your teams might be nimble. You might not have 50 people in a team. It may be a case, but not always. You might be even a one-man team or a one-woman team or 3-4 people. Okay, so in that case, you have to take up responsibilities and you have to communicate really very well. These are some things which you'll learn over the time. I don't expect you, I don't want you to just wake up tomorrow and learn all these things. But just keep in mind, give yourself 6 months, 8 months, and reach to this space where you can communicate well, where you can understand all these things. And by the way, by communication, when you say communication skills, I just don't mean that English. English is just a medium of communication. A successful communication happens when you are able to send a message across to another human and they understand it the way you understand it. Okay, use whatever language, use whatever gestures, use whatever accent you like, but get the message across and be humble while doing that. That's the point of communication. Okay, pick up some design patterns, software design patterns. So when you're building an app, you may have multiple things going on. So you may want to look into something called model, view, presenter, where model is something which interacts with the database, view is something which is shown to the user, and presenter is the classes or the logic which controls what the user gives and what is fed or fetched from the database. So follow some of these design patterns. MVP is one of the very popular design patterns. It helps you become a standardized developer. It will basically put you in the league of people who are doing similar things around the world. So you'll have ease communicating with these people when you meet them. And at the same time, it will make testing or mocking stuff very easy. Okay. Another important thing, document the code. I'm not asking you to write documentation in Word, but when you're writing something, name it like nicely. Don't say int a. What does this a do? Name it according to that. Don't also have this 52-letter long name, but try to come up with a few things which are basically telling the exact meaning as well. If you're writing function which are not very obvious of what they do, write some comment on top of that function. Imagine what will you understand if you read the same code 8 months later. Trust me, it will happen. You'll forget yourself what you wrote. Just write some app, stop working on it for 3 weeks, work on something else, and come back to that app. You'll take 1 full day to understand what's going on. So comment inside the code. That will be one of the best documentations out there. Coders will be able to understand. And last but not least, be humble, keep learning. This, as I said, is a marathon. It's not a sprint. One of the advices that I was given very early in my student days is that there are always people smarter than you. And whenever you meet them, you have to be in the capacity of learning from them, not getting offended from them. So be humble, keep learning, and ask people for help. There are always people who are willing to help you, given that you are humble enough to receive that help. Okay, so that's it from my end in this presentation. If you have any questions, I'll be able to take them.
Sure. So the floor is now open for questions. You could just write your questions in the side chat. In the meantime, Aman, we've received a lot of questions with people who've registered. So I'll just ask some of those here. So there's a question, which says that I've been working as a Java engineer for some time. So what do I need to get into Android?
If you can tell what you have been building in Java for all this time, I'll be able to answer you well. But the thing is, if you are, for example, let's say building in JSP or servlets, you're pretty much prepared. Just learn the event delegation model and understand how that works, and spend some time building some sample apps, and you'll pick it up. The good thing is that you know Java and you know the syntax, so it won't come as a problem. The only thing that you will have to learn is the IntelliJ or Android Studio environment and how things in Android work, how the life cycle of an app works. So it shouldn't be a very uphill task for you. Just have to be patient and learn a lot.
Sure. So there are a few questions that we received were around the future scope of Android and the career growth of Android developers. So maybe if you could throw some light on that for our audience.
So over the years, Android development has become very sophisticated. 5-7 years ago, you could have just built very simple app which has just 2 buttons and does something, release and people will love it just because it works in their phone. But now things have changed drastically. Unless you're building a great app, which looks great, which works very well, it's highly optimized, uses less resources, you don't stand a chance as a business. That means these businesses are looking for people who are really smart and talented. So I wouldn't say that there will be a huge amount of jobs for everybody, but there'll always be huge amount of jobs, very rewarding jobs for people who know their craft really very well. So I'm seeing this constantly, that people are looking for good Android developers and they're not able to find it. People have, the startups or the companies are literally interviewing hundreds of people every month, and they're not able to find the people that they're looking for. So this is what happens when you start thinking in a narrow-minded fashion. This is where you get stuck. You start thinking inside the box. You have to rise up and look the app development as a problem solution model, and then make yourself a person who looks at the problem and solve this with Android. You shouldn't be an Android developer just. So become somebody who knows the breadth of the technology and who can solve problems and think in those terms. Okay, too much Stack Overflow copy pasting is going to ruin you. So don't do that. Go to the Stack Overflow, look at the code, but still type yourself. This will basically help you understand how to solve problems. If you want some books, I can have some suggestions for the books. If you want fat books, I can give you fat books, which will take you a year to finish. But do that. Become an engineer. Everybody wants an engineer. Even if, let's say, 10 years down the line, the scope of Android finishes, you'll be able to pick up something else as long as you're an engineer. Just don't be constrained.
Very good advice. Be an engineer, be an agent of change, try and understand the entire Android ecosystem and not be limited to just coding or just learning the syntax. I mean, apt inputs, even during the talk when you spoke of stuff like wanting to attack the problem, thinking from a solution perspective and not a tech perspective. And those are very good, very good thoughts for our audience. So another question
Right.
is,
I lost you. I lost your voice. Okay, so I'll answer one of the questions that was asked in the group chat while we wait for Dheeraj to come back. Uh, I think nobody can hear Dheeraj's voice. So one of the question is, somebody is learning Android development since 2 months and he or she doesn't get it properly. Should he continue or leave? 2 months is pretty little of a time. It depends on how you are learning it. Try to do something for, let's say, next 2 months where you actually build something out. So I wouldn't say that you should expect that you learn something very thoughtful in 2 months. It should at least take 6 months before you decide whether you should leave or continue. So the problem now is Android has become very, very big. And there are so many resources, there are so many things for Android that you just sometimes can get confused. So your brain will take some time to figure out all of these noise and then make signal out of it. So 2 months is a less time. Give a few more months, I think. Talk to more people, talk to more experienced developers out there wherever you are, and see what they suggest. But give more time. 2 months is little less. Another question is, any forum to learn Android app, like create poll for person having basic knowledge of Android Studio? I'm not sure. That's too specific of a question. The question is if there is a forum where they can learn how to create an app like a poll. So there are two parts of it. You want to learn how to build an app. Second part, you want to learn how to create an app which creates poll. So the first part is you can always have forums like Stack Overflow or the documentation of Android itself to learn how to build an app. Now, when it comes to polling, that's a problem that you're solving. That's an algorithmic challenge that you are trying to accomplish. So look at the places which help you with thinking of logic of how polling as a problem can be solved, and how you can implement that logic in Android is the part of another forum. So there are two parts of this. So and never go for an approach where you have this certain problem and there's a forum where I can put it and get a solution of it. That shouldn't be, that will never make you a good engineer, and you'll end up relying on these forums. I've seen this again and again and again and again, that we Indians, we are, and it's a reality, we are so short on deadlines that we always have problems we want solutions for in code. Don't do that. Try to have people suggesting you how to solve them and build them yourself. If you have lesser time, okay, I think Nobody is able to hear me as well. Am I not audible to everybody? Please write into the chat. So yeah, I was saying if you have lesser time in terms of your company or your project, try to buy that time. But don't take these shortcuts, because if you get in the habit of taking these shortcuts, it won't make you a good professional, it won't make you a good engineer. So what I used to do as a personal advice is I used to turn that intelligent assistance off. So whenever I would type something and you press the dot, you get a list of suggestions that you can choose. So let's say you type object dot, you get all the methods that you can call. I used to turn that off. So I would read the documentation in my browser, always open, of a class, and then write this object and that method from these two places. I wouldn't let the Android Studio or Eclipse in back those days suggest me what to write. What that did is it made me ingrain all these methods in my head, and it made me understand the pattern, how these whole classes are working. So whenever I would go to interviews and I have to write all these things, I would remember the exact method names. I would remember how they are written. Also understand that Java is very literal in terms of English. So a method is named exactly in English about what it does. Okay. So it says, if it says get location, that means it will get you a location. So I think the upGrad team is having some technical trouble. They are not able to hear any of us, and we're not able to hear them. But thankfully, everybody else is hearing me. So feel free to ping me. You have my Twitter handle at the presentation. I would be able to help you as long as I have time. Or you can get in touch with upGrad, and they'll probably send things my way, and I'll be able to answer you. Hope you have a good time. Just know that this is a long road, and just be patient, have patience, be patient, and go slow. Let it cook. When you want a good food, you let it cook nicely. You don't hurry, otherwise jal jayega. All right. Thanks a lot. I think Dheeraj is back. All right, we have Dheeraj here.
Yeah. Great parting thoughts. I mean, don't hurry, let the food cook. Yeah,
Right.
just simmer it, let it cook. Perfect. Thanks so much, Aman, for taking time out today. Yeah,
Thank
I'm
you.
sure that you're really helpful for all
I
our
hope the
viewers.
same. I hope the same.
Thanks.
Thanks a lot.
Bye.
Bye.